Hey there everyone, welcome back to another video. Today's video is based on IGCSE Chapter 5 Physics, Forces and Matter. So let's start. Forces acting on solids. We all know that force is a push or a pull. This pull or a push can result in different effects on matter. In solids, forces can cause deformity, tensile, compression, bending, torsion, etc. Some materials can withstand this for more than others. Let me just use the draw button. Let me change this to back. So this is an undeformed object. When force is applied from both sides, the thing stretches, which is tensile forces. When it is when the forces act inside, it is compressive forces. When the force is applied here and here, it tends to bend, the bending force. And when it is twisted, there's torsional forces. Let's move on to stretching springs. To investigate how objects deform, it is simplest to start with a spring. Springs are designed to stretch a long way when a force is applied, so it is easy to measure how their length changes. Okay, so these are two things that you need to remember. Length of stretch spring is the original length plus extension, and extension is the length of stretch spring minus the original length. Okay, so let me give you all an example of what this is trying to say. Okay, let's see. Okay, I'm very sorry for the drawing, but I'm using the mouse as many of you know. Okay, let's say this is a spring. So from here to here, it is original length. But when a force is applied or a load is added, and this string comes this much. So this was our original length OL. This becomes our extension. Extension. So now what they're saying, the length of the stretch spring means the whole length of this thing. So that will be this plus this, so original length plus extension. Extension, which is this, will be the whole thing minus this. That will give us extension. So length of stretch spring minus original length. I think that should be clear. Let's move on to spring constants. And this is a very important topic. So load is the force that stretches an object. As we looked over here, this was the load. This was the load that stretched the spring. Extension is the increased length of an object when a load is attached. As we saw again, this was the. Let me change the color. Let's take pink. So as we're talking, this is our extension. It is the length which is obtained after a load is added. Next, it says spring constant is the constant of proportionality. It is the measure of the stiffness of a spring. So we have a formula for that, which is spring constant is force over unit extension. Okay, so you can also instead of remembering the whole thing, just remember K equals to F over X. Okay, so in your textbook, your IGCSE textbook, unit extension is either represented using X or E, but it's still the same thing. So you can, or let me write E. So you can use change of subjects when they ask you calculate the force, which will be K, the force, K, X. Calculate the extension, so that will be F over K. So this is how you can use change of subject to calculate force, unit extension, and spring constant. Let's go to limits of proportionality. Robert Hooke, after carefully studying expansion of springs, noticed the following. The force or the load applied does not affect the original length of the spring. The force or the load applied causes extension in the spring. The extension increases when the load increases and vice versa. This shows that the extension is proportional. This is a keyword. It's proportional to the load, that is F equals to Px. What this guy was just trying to say is that Let's say load is 2. When load is 2, our extension will also be 2. I mean, the values could be different, but then let's say here is 4. So they will always be proportional. That means they'll be same. Let's say extension increased by 2. That means the load will also increase by 2. Okay, and also one more thing, this thing will only be proportional till the point of proportionality or the elastic point. After this, this will curve because once it has crossed this limit of proportionality, the spring will deform. Okay, I don't think I added it here, but the spring will deform. You have to know this deform after the spring has after it has crossed the limit of proportionality. So this is something you all must remember. Let's go to pressure. We all know pressure. Pressure comes into play when force is exerted on a surface. Let me draw that here. Change color to white. Okay, let's say this is our force and this is our area. So the force that is exerted here is the force over the area. So weight acts in the direction of the force of gravity, that means vertically downwards. Upthrust, the vertically upward force in fluids, liquids and gases. So let's say I have a fluid here, or let's say there's a swimming tank and you're swimming in it. The force that will send you up is called upthrust. These forces, when balanced, cause flotation. When gravity is balanced with upthrust, that is what allows you to float on the water. Submarines and marine exploring vehicles are designed to resist the pressure caused by these forces on them. They have a particular design. They are designed to have curved surfaces effect. This helps decrease the pressure on the object. They are made of thick metals, which helps the object resist pressure acting on it. Note that pressure on the object increases as the weight of the water above it increases. That means the deeper the object goes, the higher the pressure acting on it. The deeper the thing goes, the more pressure acting on it. Pressure in liquids is much higher than pressure in gases because the density of liquid is generally higher than that of gases. Pressure in fluids increases as the depth increases. The base of the dams or tanks are built to resist the high pressure applied on them. A, okay. A large force pressing on a small area gives a high pressure. We can think of pressure as the force per unit area acting on a surface, and we can write the equation for pressure. Sho- As shown, pressure is force over area, which is P equal to F over A. The unit will be N over M squared or N M minus 2, any of them, N over M squared or force over area. Let's go on to pressure, depth, and density. That will be the last thing for today. We have seen that the deeper one dives into water, the greater the pressure. Pressure P is proportional to depth, which is h. We use the letter h for height. Twice the depth means twice the pressure. Pressure also depends on the density, rho, or P, which looks like a P, of the material, where P is the Greek letter rho. If you dive into mercury, which is 10 times more dense as water, the pressure will be more than 10 times as great. You can write the equation for the change in pressure as a depth h and a fluid of density rho. Change in pressure is basically density times acceleration due to gravity times depth. I think that'll be all for today. I hope it helped. Like, share, subscribe, share it with all your friends, and all the best in your exams. See you next week.